Hey, happy Wednesday, everyone. Today is July the 7th, and I'm very pleased to welcome you all to this third sessions of technical webinars that we started in December 2020. And I'm pleased to see you all, guys. So my name is Patrice Marcel. I'll be your host today for these sessions. But before we go on, I think that the session here, the session title is on the OE procedures and shop floor. We'll get that more in detail. But before we go, just a little bit of housekeeping here. These are like typical 60 minutes event that we do. We have one usually in March, July, and November. We do that every year. We try to tackle the technical, then a management session. So we have another one tomorrow that I'll just get at in a minute. Um, and these are the topics are usually follow-up items that we have from the CCIF. And we welcome everyone that would have suggestions or somebody that would like to be a speaker to these events. Please just go online. You can write to Caroline at caroline.lacasse@ccif.ca, or there's a form online that you can go and just fill and submit your application. We'll be more than pleased to have you to come in and present. Tomorrow we have a session. Tomorrow we touch on the HR best practices. So we're going to look at onboarding. We're going to look at developing and retaining employees. So we do that in the form of some kind of a panel discussions. We're going to have a shop owner from Saskatchewan, a shop owner from Halifax, and we're going to have an HR director from a big dealership group from Montreal. So we're happy we'll be happy to see you there as well. So moving on here, a little bit of housekeeping. If you want to ask a question, we encourage you to do so. Just use the chat option or the Q&A on the right end of your screen, and just type in your question. I'll try to filter those as we go, or keep them towards the end, where we're going to have some kind of a closing comments, and we're going to probably tackle some of the questions that we have during. So please, if you want to participate, we'll be more than happy to answer your questions here. I mean, this would not be possible without the support of all of our sponsors, especially in those times. It's not easy. I mean, being one of them, I can tell you that it's not easy, but it's important. So we want to thank everyone for their support. So we're just going to take a few seconds here on each of those slides to make sure that we thank them. I mean, those companies here, they help us to support us, so we are able to do these kinds of events, to do the face-to-face events that we put on hold for a year and a half now, but we were able to still be doing these. So yeah, it's important that we thank them, and that's because of them that we can do this. So today's session is the OE repair procedure on the shop floor. We've talked about OE procedures for many years and many events, and this is not going away, and it should not be going away because of multiple reasons. And as I was kind of preparing to open this webinar here, I was just thinking that every time I hit the road, and I go on the highway, I've been driving connected and ADAS equipped cars for the last 6 years. And when I travel back home and I hit the road for 8 hours on the highway, and I'm going 125, sometimes maybe I go a little faster, I want to make sure that my adaptive cruise control, my pilot assist, operates properly. I want to make sure that it will brake if I don't see the hazard happening. And it has happened many times since I've been driving those cars. And I like this. I mean, the seatbelt tensioner and all this. Wow. I mean, this is great. And I want to make sure that if my car is being repaired or fixed, or I want to make sure that it goes back to what I'm used to, and exactly that it will behave the way it is supposed to. The way it is supposed to. So I think this is important that we keep talking about this discussion. And today specifically, we want to try to bring this level of discussion to the shop level, to the shop floor, about how is this happening at the shop level? How do we do it in a shop? Okay, we understand the importance of applying those procedures. We have a pretty good idea of where to find them. But now, how do we make this happen on the shop floor? And that's the topic that we are going to be touching today. So to do this, and before I go to the slide, let me just go back here. We're going to do this in two parts. The first part is we're going to have FAF AutoWorks, Jeff and Ryan, that are going to come in and are going to explain to us, and we're going to do this through some videos on how it happens at their location. How do we do this at their location? So that's part one. I mean, they've been trailblazers in this. They've been applying those procedures forever. I mean, they've been a reference on how to do it. I remember hearing at previous events about how they were doing this. So I think they are absolutely the best one to come in and to talk to us about how it's been done and how they've been doing it for many years. Now, part two now is going to be, we're going to talk to an independent shop, which is at the other end of the country, and say, oh, okay, Peter, how do you do that? How do you do this as an independent? So we have Tawasin Collision, who is going to join us and talk about, and that's going to be part two. So let's start here with our part one here, which is about how we do it. So to do this, again, as I was saying, we have Jeff and we have Ryan. So Jeff, do you want to go ahead and introduce yourself?
Sure. Good morning, everyone. It's a pleasure to be here. I'd like to thank Patrice and CCIF for including us in this discussion today. So my name is Jeff Paps. I'm the general manager and partner at FAF AutoWorks. I've been in the automotive industry for 30 years this September, specifically with FAF. Before that, I was in automotive, but in the manufacturing side as a tool and die apprentice, and grew up around cars, raced cars professionally over the years, and still racing today, but not at a professional level. And, I'm passionate about the collision industry and cars in general. So I've been here a while and continue to try to make a difference. So.
Thank you, Jeff. And also we have Ryan. Ryan, do you want to go ahead and introduce yourself?
Yep. Good morning, everyone. So as it stands today, I've been managing collision centers for 15 years now. I've been here at FAF AutoWorks since 2013, working with Jeff. And, prior to that, I've, managed collision centers that were part of a dealer group, either part of a dealership or an independent or franchise. So a lot of experience managing different types of shops. Just like sort of like how Jeff was, I grew up around cars. My grandfather owned a Ford dealer. My father owned a GM dealer, and I've been passionate about cars and the industry ever since. So that's a little bit about my background here. Jeff and I were fortunate enough in 2015, we were named the Canadian Body Shop of the Year. We've been following OE repair procedures ever since our first certification. And in 2019, awarded the Verifax Medallion Award, which is we were the first shop in Canada to get that. So there is a very strict focus here on the following of OE procedures each and every single time. So that is a little history about me and what we do here. So.
Okay, well, thank you. So I think what we want to do here, and first I want to really acknowledge both of you guys for the work that you have done. And I mean, we're just about to start looking at 6 or 7 different short video segments here on different topics. And this work was all done by the Marketing, Communication, and EV department at FAF AutoWorks. So this is fantastic. So. I would, Jeff, Ryan, do you want to give a little business profile of FAF and before we move to those videos?
Yeah, absolutely. Thanks, Patrice. So Bath Auto Works has been around since 1997. We're a small shop, 2,500 square feet, four employees, including myself. And today we're in a 42,000 square foot facility with 40 employees. Pre-pandemic, we were just shy of $1 million a month in sales. And we were at that time 46 staff. And we're certified with Volkswagen and Audi, BMW Mini, Porsche, Tesla, McLaren, and FCA, Nissan Infiniti, and Honda Acura. And we're also a Verifax, as Brian mentioned, we're a Verifax facility, and that is essentially an independent auditor who comes in once a month and verifies our repair processes against the OEM procedures, both in the repair procedure, but also tools, equipment, health and safety as well.
Okay, well, thank you. Thank you for that. So so I think that the question that I would have to start, and that would going to lead us into starting to look at those at the videos that you guys produced. What is the process? Can you just lead us into what's the process at FAF to apply those procedures when the car comes in? Run us through, quickly from beginning to end. At what point is the OE procedures being researched and all that? How do you guys do this? And then we're going to start looking at those videos.
Sure. So, I mean, really the process starts from the time the car arrives. At our facility, we have repair planners. We also have customer service reps that those are the individuals that deal directly with the client. They handle the intake of the vehicle. And the repair planner doesn't deal directly with the customer, and they might deal with the appraiser, but they deal with the specific disassembly of the vehicle once the vehicle is checked in and with the technician on the shop floor. Our customer service reps, they are the ones that have the ability, same as everyone does here, to look up the build sheet. They can look up, repair procedures depending on the manufacturer and the type of repair that that they're getting into. On a very basic level, they start the process from that time that car arrives and prepare that work order with the repair procedures for the repair planner. The repair planner then will actually go further in detail with it and review what the CSR has provided them, but then also then go in and access the system for more repair procedures depending on what they're uncovering during the repair planning process. So I know the first video that we're going to show kind of explains a little bit about what that first step is.
Okay, so yeah, let's run into this first video here. That the title is the build sheet. I mean, when I was looking at it, it's the build sheet. So let's play the video, and then we can have a little discussion around that.
The vehicle build sheet is the primary thing that you want to research first. This is what contains every option the vehicle has from the factory, and that is what you're going to research when you're looking at what options the vehicle has to determine what kind of repair is needed or how the repair is going to be affected by that build sheet based on the options the vehicle has. So being a manufacturer certified collision repair facility for many brands allows us access to manufacturer repair procedures, specific website portals where we can obtain this information, whereas other facilities would not have access to it. There are many ways to obtain a build sheet. For us, being a certified facility, yes, we have access to BMW, S-Gate, the Web EPC, the parts catalog, or if it was Audi, we would have access to what's called Access Audi, which gives us repair manual procedures, collision repair data, those types of information where we can easily obtain that. Someone who's not manufacturer certified might obtain that through a parts department. They might get it through an estimating system. The estimating system, however, we don't personally rely on that because we get the information straight from the manufacturer. But the estimating systems do have the capability to decode VINs. But at this point in time, I'm not 100% certain that it is accurate as what we would achieve from the manufacturer itself. The color code information can be found oftentimes on the VIN label. If it's not on the VIN label, there are other places that it can be found, sometimes under the hood, sometimes in the owner's manual. We rely on the build sheet to get a paint code for many of our certified models that we would work on. It really is a key piece of information to get the paint code from the build sheet. Oftentimes it might not be available on the car itself. So we would get that information from the build sheet as well as various other options that the car may have specifically when it comes to advanced driver safety assistance systems.
So Ryan, and Jeff, the build sheet here. So that kind of, when I saw this video for the first time, I said, well, yeah, that really is interesting. The build sheet, I mean, we used to rely a lot on the VIN, as you mentioned, and we look at the VIN, and for us, the VIN tells us information. The build sheet, I mean, the VIN is just one component of that build sheet. That build sheet is really in complete detail of what the car is made of. So that's so you guys, the first thing that you do is that you pull out the build sheet of each of the cars that goes to your shop.
Yeah. So, one thing, you heard me talking about something simple like the paint code. That's something that our customer service reps will identify at the very beginning to alert our paint shop staff. At that point, we have someone that is verifying colors when the vehicle comes in and is doing spray outs as early as possible in the process to make sure that when that car is ready for paint, we don't have any color matching issues or things of that nature that are going to prevent us from getting that car out in a timely manner. The other basic components of the build sheet are just the vehicle options, right? We want to know what systems are in place, what kind of assistance systems does that vehicle have that are related or that we might find damaged from the accident. It tells us how to approach a repair in that what do we have to be aware of when we're disassembling a vehicle? What calibrations might be needed if this vehicle has, Patrice, you mentioned your vehicle, adaptive cruise control, automatic emergency braking, those things that you have to be aware of when you're disassembling a car, as well as when you're reassembling that car, if there's calibrations to be done. Getting that build sheet and identifying what features or options that vehicle has at the beginning makes the process down the line that much easier and ensures that everyone who's working on that car is aware of those systems that are in place and what needs to be done down the road to ensure those systems work when the vehicle is finished.
Okay, so do you have one person doing it? Is that always the same person, or do you have multiple people doing this kind of research?
So pre-COVID, as I mentioned, our customer service representatives would obtain the build sheet. As soon as they intake the vehicle, they obtain the build sheet. They put it directly into our management system so that it's accessible for everybody. Then we currently have two customer service representatives, and we have two repair planners. Those repair planners, again, they have access to the manufacturer portals there that they can access any information they require that they need for doing the repair planning process. So they also have access to it. So we have technicians, obviously, that they go through the training, the manufacturer certified training. They have specific logins for technicians in which they can also access the repair procedures. But we need to make sure that and every repair procedure that we do research goes into our management system and is accessible by anybody at any point in time who's working on that vehicle.
Okay. Okay, so the next video talks about the bumper repair, and I like when in the introduction. I mean, this is a lot of, as you say, Ryan, in the video. I mean, a lot of those little hits are bumper repair and fender benders. So I thought that was an interesting video to look at. So let's bring up this bumper repair video first.
Repairing bumpers is probably one of the most common things that any collision center is going to be dealing with on a daily basis. Majority of collisions end up being minor fender benders, and therefore bumper repairs or bumper replacements are the most common thing that we would see. So when repairing bumpers, we really have to look at the manufacturer procedures on bumper repair, and each one is specific to that individual manufacturer. And there's one particular manufacturer where if there's a crack beyond a certain size, we are not able to repair it. If there's a hole in that bumper beyond a certain size, we are not able to repair it. That's just specific to the actual plastic welding or plastic filler repair that we might do on that bumper. That doesn't even take into account the repair procedures which tell you that you can or cannot repair that bumper based on where the damage is because of the radar systems that that vehicle may have. So, for example, a few years ago, if there was a bumper repair on, again, a specific manufacturer, you weren't allowed to repair it at all. Just any paint at all, their repair procedure said that's a replaced bumper. They've since updated that repair procedure to say if it is in with a certain area, a certain radius of the radar systems located in the bumper, then you can't repair it. So again, the importance of researching repair procedures every single time that you repair a car is so important, because those repair procedures can change, and you might repair a bumper that is not repairable or vice versa. As well, when it comes to the radar systems, paint millimeter thickness, plastic repair millimeter thickness, any kind of material can also impact the radar systems that may or may not be functioning after a repair.
So the question that I had as I was looking at this, are we, if specific to a bumper, and when we have an information from a specific manufacturer about the thickness and about the area, does this apply to all manufacturers? It may sound like a stupid question, but is this because I fixed like an Audi today and I'm being told that I cannot do anything in that certain radius, that the same logic would apply to a different manufacturer?
So that's actually a really good question, because we obviously, you heard Jeff explain how many manufacturers we're certified for.
Mm-hmm.
And the importance that we try to impress upon everyone is you have to research those procedures every single car. The reason being, and it doesn't matter if it's a specific brand, the procedures can be different for a different model, or depending on where the radar sensors might be located in that specific model of car. So it's not specific to a model or specific to a brand. You have to really look up every single vehicle that you're working on, and not just simply because of those specific repair procedures. It's just that the procedures themselves can actually change. You heard me talk in the video about one manufacturer that has updated their repair procedures, so now we can actually repair those bumpers depending on where the damage of the bumper might be located. Whereas before, anytime there was a little scrape or scuff on it, you'd have a customer come in and they wouldn't understand, well, why can't I just paint it? Well, the manufacturer says you're not able to, based on the options your vehicle has, because those options may not work after we're finished painting that bumper. And I've actually seen a case where there was a manufacturer repair procedure that didn't exist for a bumper repair. There was nothing in their literature that said you couldn't repair it, and we've seen a bumper repaired, and all of a sudden the sensor didn't work afterwards. I've been in touch with that manufacturer, and they're aware of that issue. But again, it's something where there's nothing in their literature that says that you can't repair that bumper. Albeit that was one specific case, but I haven't run into that problem in any other times. And we've also had, there's another manufacturer out there where it tells you that the bumper can only be painted once. So how do you test that? How do you know sometimes? And they actually tell you to scratch test, sand it, and see if it's been painted, and if so, then you have to replace it. So.
Yeah, no, and I can add to this that being working from coatings company, I can tell you that even the color will have an impact on the not only the thickness but the color code, the specific color pigmentation will have an impact on this. So very nice. Now the other one that I would like to look at, because bumper is kind of cosmetic repair. Sometimes that we identify that, but let's watch a little segment here that talks about more about structural repairs here. So let's look at this one.
I think the first thing you would start with structural components is the composition material, right? So what we're seeing is mild steel. We're seeing a range of high strength, ultra high strength aluminum. We're seeing cast aluminum. We're seeing carbon fiber. So the first step is to identify the material with which you're working. Once we've determined what the car is made from, that guides us as how we're going to approach our repairs. One of the things that we take into consideration is the manufacturers have specified different approaches and even different possibilities of repairs. Tesla, for instance, has told us that ultra high strength steel really shouldn't be repaired and needs to be replaced. So that puts a whole different complexion on the repairs to the vehicle. You've also got to carefully match the technician with the job. You can't just assume that we're going to do it the way we've always done it and everything is mild steel, because that's not the case anymore. You need a technician who's had specific training, both in panel repairs and welding. So Audi, for instance, has an in-depth welding course that we send technicians away for a week. And the welds are judged by x-rays at the end. If they're going to pass the test, their x-ray welds have to be sufficient for Audi standards. Once you get into things like aluminum can be repairable, but it's not the same as steel. So you're into different techniques that all have to be trained and learned. And you're also into different equipment. So tools that you use on a vehicle made of steel can't be used on a car that's made of aluminum. You can't cross-contaminate. So you're into an investment of a different set of tools. The welders that you use on steel can't be used on aluminum. So you have to have a dual stream of tools from the welding perspective. But carbon fiber is not just an appearance part. It's amazingly light, it's incredibly strong, but the repairs we can do to it are quite limited. For instance, on the BMW G11, G12 bodies, they have a carbon core. And in those instances where you suspect damage, you have to involve the manufacturer. So their instructions are very strict that the carbon has to be photographed. You have to provide them video of the carbon fiber core of the vehicle. And if it's damaged, that's something that the manufacturer will determine. And you are then leaning on the manufacturer for what you can and cannot do, and they will tell you specifically what's available to be done with a carbon core 7 Series, for instance. But you do see it in things like hoods on some BMWs, and the repairs you can do to that is limited. All of this leads us back to the certifications, and the certification is an outgrowth of both the training and the equipment. So there's two parts to a certification. So we're certified as a Tesla approved body shop, the TABS program, and Tesla involves, with the exception of carbon fiber, they involve all of these materials. So our technicians spend a lot of time doing training. It's constantly ongoing. So it isn't just you do a training course and you're finished. It's always updating. You get emails that there's another online course to do. There's another online course to do. So it carries on and carries on, and it's not static. There isn't, we've always done it this way, or I was once shown it was this way. BMW is a brand for whom we're certified, and it's very important with BMW to research your procedures each time you do the repair, because they do change. Not just BMW, all the manufacturers, but there was recently a BMW replacement that we did of a piece of sheet metal, and I've looked this up a dozen times, and I'm quite certain of the way it was put in, and they've changed their minds, and they've revised the procedure, which was quite a surprise, and it was important to look it up in that instance. We're also certified with Porsche, Audi, Volkswagen. We can do the Audi aluminum, the Porsche aluminum. We're one of the few shops that can do that. Again, that goes back to the training, that goes back to the equipment that we have.
So, well, that's a very interesting piece here. There's two things that really is catching my attention here. The first is that obviously, if you don't have access to the information, you cannot tell. You can tell it's steel, but you cannot tell what kind of steel it is. I mean, obviously, I mean, just the magnet thing, I mean, is just going to tell you if it's steel or not. So you definitely need to have access to this. But what I really would like to, and the carbon fiber core and all this, I'm like, wow, this is kind of that's complicated. But what I really liked here at the beginning, and what Martin, I believe is his name, what he said is that it's important to match the tech to the job. Can you explain? Can you just put a little more information about what you mean by matching the tech to the job?
Yeah, I think it's important to make sure that you understand who your technicians are and what their capabilities are. You don't want to, from a management standpoint, you don't want to, put one of your highly skilled trained techs on, just repairing bumpers all day, or give one of your lesser skilled technicians, an essentially like a mountain of a job where it's highly advanced and repair procedures are looked up every step of the way. You have to make sure that our technicians have gone through the training. For us specifically, we have technicians that are trained on specific brands, and they work on those specific brands of vehicles. They're accustomed to it. They're used to looking up the repair procedures for those specific brands that they work on. Martin mentioned Tesla, that we've been Tesla certified for a number of years now, and but all of my technicians are not Tesla trained. The training is ongoing, as Martin said, and we're training more and more, and trying to get everyone trained, especially when it comes to the high voltage vehicles. But if someone has done or completed the training for Tesla, for example, they're not going to work on a Tesla vehicle in our shop. There is essentially there's a risk for the car not being repaired correctly, but there's also a health and safety risk to the technician themselves if they don't understand the types of materials or the vehicle they're working on.
Okay. So yeah, very nice. And at that point, we're going to make a little bit of a shift here in the sense that we're next few segments we're going to look at and listen to are around electric vehicles, because I think this is extremely important that this is also like technology that is really coming up to our shops here, and we really need to understand what we're dealing with here. So let's look at the first one here regarding electric vehicles.
Electric vehicles is not something I can speak about briefly here. They're becoming an enormous segment of the market. We're seeing more and more of them on the road. Tesla obviously is probably first and foremost, but we are seeing Volkswagen make an enormous investment in electric vehicles. Audi vehicles are here. Porsche Taycans are a feature in our shop. We're seeing all of these vehicles. They're not the same as an internal combustion engine vehicle. There's a lot of things that are very similar, but there is a whole host of additional safety precautions that you have to be aware of. And again, this involves a lot of training. An internal combustion engine that's turned off really isn't going to cause you a lot of damage. But an electric vehicle with a big, enormous battery in it and some very high voltage, is a cause for concern because people can be injured and killed working on them. To avoid that, we have to be very careful about depowering these vehicles, how we handle them, and who works on them. Again, you've got to point those vehicles towards only technicians who are trained and certified to work on electric vehicles. You can quickly find yourself in a simple repair that you think you can easily do without touching anything high voltage. Suddenly you've come across a charging port or a high voltage cable that if you don't have the training, you can end up quite badly injured. One of the things that we do is electric vehicles have to be monitored and maintained. We do a weekly check of any electric vehicle that's on the grounds to make sure that the battery is charged up to a serviceable level. We are able to remove batteries here for Teslas, but as a for instance, Audi and Porsche have been quite specific that batteries removed from those vehicles have to go back to the main dealer service department, and Porsche has been quite strict in saying that these batteries have to be quarantined in a special quarantine area. So the danger exists in leaving these lying around. You can't do that. And you can't take a very casual approach to anything that's high voltage. Even a lot of things that you see, as a for instance, BMW has some medium voltage, 48 volts, and that's enough to badly injure or even kill somebody.
This is yeah, this is nice. Very nice visuals here, and very good information. I think that what is really catching my attention here at that point is the kind of correlation between an internal combustion engine that is off. I mean, is not really harmful or dangerous, but an electric car that is switched off. I mean, still the battery is there, fully charged, fully powered, and it can be very, quite a hazard, and it can even be deadly if we're not paying attention. So that is very a very good piece here regarding the electric vehicle. So probably what I would like to do here at this point, I just want to make sure that we have some time, and we can bring Peter in this conversation at some point. So if we can probably just move to the video that says conclusion, and then we can have a quick discussion. So can we move to this video called conclusion? We're just going to skip one here, two, I guess.
So ultimately, all of this benefits the customer. The customer is going to make a choice where they get their electric vehicles, their EVs repaired. I mean, people sometimes shop for the lowest price. They want someone who can do it the quickest. But that doesn't necessarily get you the best result. People bring us their electric vehicles because we are certified with Tesla. We are certified for Porsche, Audi, Volkswagen, and BMW. So the customer's choice in bringing the car to us is going to bring them the best result. There's not going to be any guesswork involved with fixing something that is, I mean, fairly new technology. Electric vehicles certainly haven't been around in their numbers that we see them now as long as an internal combustion engine vehicle has been. So there is a bit of catching up to do for the industry at large, certainly to get to where we are in terms of our training, in terms of our experience with these vehicles, because we have been working with them initially from their outset. So again, this goes back to the customer getting their vehicle back in the condition it should be. Anybody can bang out a dent and hope for the best, and that sometimes works, but doesn't always work. Especially when you start to get into structure, especially when you start to get into mixed materials, and especially when you get into high voltage and medium voltage electrical systems, guesswork just isn't good enough.
That's very well said at the end here. So, hey, thank you, Jeff and Ryan. Don't go away. We're just going to move to Peter here, and we're going to come back at the end with some kind of a recap and some questions that we have. But wonderful material. Thanks again for all the effort and all the good quality stuff here. And Martin, I don't know if Martin is online today, but they're a good job in speaking and explaining. This is great. So, Peter. My friend Peter Sickley from Sawasan Collision, British Columbia. I hope you're surviving the heat wave here, Peter.
last week. The heat wave was last week. This week we're down to a nice. To this morning, I think it was around 20, 22.
Okay. Well, very nice. That must have been a pretty tough week for the technicians in the shop.
There's always a reason why the work can't get done. You know, it's either a holiday, it's snow on the ground, it's too hot, it's this, that, man. You sometimes wonder where your actual production days are. Yeah, it was tough, but we had a nice airflow drop here, so it wasn't deadly.
So, Peter, tell us a little bit about yourself and about your business.
Okay, we'll just leave me out of it to some extent. Tawasin Collision has been here since '95. We've got 16 employees. Our space hasn't grown that much. Probably started around 6,000 square feet. Now we're close to 10,000 spread out. As you see from the picture, it's a bit of an odd structure. We're spread out over 3 buildings, looking more like a gas station or an automotive service place than a body shop. So every move is in and out of the shop, which has the advantage of the expensive lease I'm paying. At least I'm not paying for driveways. Our annual sales are about 3.3. Then everybody uses the pre-COVID thing. So the pre-COVID sales were 3.3. We're clawing our way back to that. To me, that number is important because I think that I don't see this overall, but I feel that you need to be turning as an independent 2.5, 3 million, 3.5 to be able to do the work you have to do now. The research that's involved, the equipment that's involved, everything else. You know, you can't do a return on investment on a $40,000 welder because you need that $40,000 welder to do that one job. So you can't do the work without the welder. So you need the scale. And I believe the minimum scale is right around where we are, like $3 million. Okay. I would be happier if I was turning a little bit more than that with the same space. So there's a lot going on.
Yeah. So Peter, I remember we had a discussion in preparation to this webinar, and I remember you shared some of your thoughts, and I kind of took these thoughts and I put them into those slides here, and what I'll do is I'll just share them, and then I'll ask you to to expand a little bit on what you meant. So if we can go to the slides here. Hopefully I'm at the right one. So yeah, so here's the deal. I mean, with what we just saw from from FAF and how they operate and how the importance of applying those procedures and everything that is involved, how does an independent shop handle the situation? So the first thing that Peter, one thing that he put down on paper is that with each year, the active fleet being repaired gains added complexity, and more cars requiring research and careful analysis before the repair starts are becoming part of the repair mix. A time will come, not that far in the future, where the incorrectly researched repair will fail almost every time. We're not quite there yet, but almost every time. That's pretty strong words, Peter.
The first thing I will say to that is I am not pretending that what I'm saying here is the answer. This is something that I strongly believe in. This is how I look at it, but I'm not presenting best practices. I'm presenting what my beliefs are and what I feel needed within the industry, and certainly in my facility. But going back to the comment about every repair failing soon, is 20 years ago, you could look at a car, look at the damage and fix it because it was all made out of mild steel and had nothing for electronics. Can't do that anymore. In your introduction, Patrice, you said that you have gotten quite used to how your car behaves. We can't fix that if we don't know what's on there. What we're able to do, what the industry gets away with now, is they can do the incorrect structural repair most of the time, and it will never cause trouble. Not that they will get caught for, because if you do that welding incorrectly, or you weld something that's not supposed to be welded, or you straighten something that is not supposed to be straightened, most cars will just drive down the road just fine. There's no issue. Everybody's pretty happy. The car's just driving down the road. It won't work really well in the next accident, but that doesn't show up right away. The car just drives down the road. So that is not a failure in the sense that the car's back the next day because now you're having to fix it for free because something's wrong. What will turn into a failure is if the electronics don't work and the driver has become used to those electronics and takes the car away and comes back the next day, hey, my blind spot thing is working a little bit funny, or I was just, I made a lane change and somebody almost hit me. What's going on here? So those have to be right every time. And now we're getting $25,000 cars that have that stuff on. Every car has that. So what do? You have to fix it. The nice thing of it is the people that are going to be doing the work, being aware of the electronics, they're not just looking at electronics. They're going to be realizing, okay, we're doing this. We need to pay attention to the metal and structural repairs too. So everything will get better once it's demanded that the drivers are happy with the cars. And the first step towards getting there is just knowing what's in the car.
Yeah. So Peter, who's doing it in your shop? I mean, is that do you have the technicians doing the research and getting the information?
We do not. And the reason that we don't have the technicians doing it is because the technicians in the environment we work in now, the only thing we get paid for, like absolutely the only thing we get paid for is the physical fixing of that car. So, which means that your front office people aren't making you any money, your back end people aren't making you any money, the person washing the cars, the only people making you money and keeping the place alive are the people fixing the cars. If they spend an hour figuring out how to fix that car, they've been paid zero for that and nobody else is backing them up. So no, the technicians do not do the research on figure out what's going on. The other aspect of that is that OEM procedures require interpretation. They're not, if you were to follow every single rule, you would be writing off every single car. Without getting into it, you can do a very, very good job of fixing the car. High integrity, safe repair, everything right, it all makes sense, and you have not followed every single step every single time. So you need to make that interpretation as to how you're going to apply the rules based on your experience. And if you allow the technicians to do that, then all of a sudden you are being the front man for 4 different collision shops because each technician will do it differently. So it's very important that research and the interpretation of the methods is done before it gets to the technicians, so they're given the instructions to do the work consistently each time.
So in that case, is who's doing it? Is the estimator doing it?
The beleaguered estimator. And now we're going back a few years, but it's still the reality of the estimator who is supposed to check parts prices, is supposed to make sure the technicians have what they need in the way of parts, the work orders, everything is ready. They're supposed to keep the customer informed. They're supposed to famously cross their T's and dot their I's for the insurance company. They have to make sure that part that they're selling for $147 is not available for $132 because then they'll get in trouble for that. So they've got a ton of time, a ton of pressure on them already. And also, they're not getting paid to do the research, and they need to be feeding the technicians on the floor. So that work has to go through. Doing the research is not easy. It's complicated. It's complicated work. And once again, you have to pull that into somebody that has some expertise on doing that so they can get that information quicker, feed it down to the estimators. The estimators can then build the estimate or the repair plan from that, and off it goes to the technician. So no, the estimators are not the right guys to be doing the research.
So in that case, who is doing it? Or, I mean, who are we talking about? A new role, and is that a new set of skills here that we're? I mean, this is quite new. So who's really doing it?
It is very new, and I spent from probably 2018 through 2020. I spent a lot of money doing something. Okay, let's take a serious look at this. So we looked around. The person I ended up with was actually a PhD level systems engineer. We didn't so much need the PhD level, but we needed somebody that understood research, that understood report writing, that understood the importance of procedure. We put this fellow onto the onto the role of gathering the information. The first step was to develop a program so that the information he gathered could then get fed out to the rest of the facility, to the estimators, to the technicians, and otherwise. But then his expertise, by the time he is done, he would be able to, he would come in the morning, take a look at yesterday's, the intake from the day before, and from looking at the serial number, the pictures of the damage, and a few notes, he would then, first step would be he would decide. If it was a 12-year-old Honda, he wouldn't write a whole lot of anything. If it was a 2018 or 2019 2019 Toyota, well, then he'd get to work, or the Honda. He'd get to work and he'd figure out, okay, what's his car have on it? What is the car made out of for metal? What do we have for electronics? What do we have for one-time use parts? What do we have for battery disconnect, reconnect procedures, all the rest of that sort of stuff. And that information would then get sent on to the estimators. The estimator writing the estimate would have in the background, say, well, I can't put a 6-hour repair on that frame rail because that frame rail is made out of a material that can't be replaced. So right off the bat, we have to replace that frame rail, which means the engine has to come out, which means we're probably looking at a write-off. And that saves a whole lot of time over getting the car into the shop, set up, finding out. So yeah, we had somebody isolated doing just that work.
So it's a new skill set here. So I mean, I guess that's work if you have a decent size collision center. I mean, you can probably have a full-time person that does that. But if you don't, if you're a smaller size, I mean, is that some kind of a role that can be shared with another one, or what do you think?
I don't. That to me is a maybe. I know when we spoke a few weeks ago, I said no, but I think I put it down to a maybe. From the work that we did and the researcher that was here, we felt that if he needed something about twice the size that we had. If you're turning $5 to $6 million a year, let's say if you had five or six people doing the estimating or the repair planning, then he would be able to stay busy keeping those six going. And there's another part of it which was really quite good, is that he would do the basic work at the beginning, but then they had another thing which was also automated called on demand, where the estimator in the middle of doing his work, or sometimes the technicians in the middle of doing their work, so we've run into something. A message would go back to the researcher. He would then answer that question. The thing that we liked about on demand, that we had to be very cautious of, is that on demand implies that you need to know something. Where if you really know nothing, you don't even know you need to ask the question. You just blindly go along. So you don't leave it to, it's a little dicey leaving it to that question. Now, if you're to share this between two facilities, let's say an independent went to two different, an independent met, partnered up with somebody down the street or around the corner, you would have to have, I think you would have to have the same business philosophy. You'd have to have the same belief in how cars are supposed to be fixed. Not absolutely, but it would be a little bit tricky for the researchers to say, all right, these guys really like this, these guys don't like that, so here's what I'll feed them. I concluded that something that would not work is to have this on a contract basis where you're paying per job to have it researched. There's too many problems and just odd costs with that sort of thing. So I took it a step farther. With everything that's talked about now, you always have to raise the issues of the COVID slowdown. So I had the next step after we developed the program, which was going to start doing some operational development. If we're not doing any work, we can't afford to do that. So we moved the work too quickly to operations, and we found out that it really doesn't work all that well, because operations guys are operations guys. They're doing stuff, which is what they need to be doing. And so to sit down for 45 minutes or an hour of just straight researching something or looking something up, that doesn't fit in. That doesn't fit in with what they're doing. They're starting to understand. I had one person who was doing that, supporting the other three, but it wasn't working all that well. But there is room for a new role within the industry.
Yeah.
And
I guess what this is kind of bringing this discussion to is that are we looking at a new role, a new head count in the shop, or are we just going to take some of the skills or some of the tasks that some of the folks are doing now, moving it to somebody else and kind of reshuffle the skills here? So are we having a head count, Peter? Do you think?
no, what it would be is, if you have two estimators or two repair planners, you're kind of stuck. You're going to have to do what you can. That's a little bit tricky. If you've got three and they're starting to get overloaded with the research and the work is going through, so you're getting paid well enough, or they're just getting overloaded, then you don't add a fourth. This now in 2021, you don't add a fourth estimator. That's where you add the research, the operations level
Okay.
researcher. And that operations level researcher is somebody that generally does not exist in the collision industry now. Um, People in the collision industry like cars. It's mostly why they're there. They like cars, they like fixing stuff. They are not, by training, by the nature of the industry, they're not the best people in the world at reading stuff, and certainly not the best people in the world at writing steady, consistent reports. So we think where this will come from is the the engineering technologist, the sort of guy that would sort of person that would go through 2-year diploma course and then get stuck on a bench testing 40 different versions of the same of the same thing. That's what technologists do. But they're disciplined. They're writing reports. They're paying attention. You take that discipline and say, here, we'll give you something else to do. Rather than just testing this little piece of equipment each time, we're going to put you into this environment where you have to do new work. You have to take your report writing skills, look at this damaged car. Every job you do is going to be different. They'll be quite excited by that. And they'll have, so that respect for process and an interest in cars. They're then supporting the three estimators who are they're now able to do their work a whole lot better. The technicians can do their work better. And there's a lot of potential in that. If there isn't quite enough time to keep them busy with the three estimators, well, then you put the calibration onto him too, because if he's dealing with, there's no money in sending the car to the dealership for calibration. You cannot just pretend the calibration isn't needed. But there are many situations where you find, especially the dynamic and certain static calibrations, we can do these in-house. So you assign him that physical task along with his research, and I think it would be a very effective role. Rather than 4 people struggling, you have 3 doing nice work being supported by the 4th.
Okay. So probably, I mean, I think the last slide that I had here, Peter, was about what's the status with as a conclusion? I mean, independent shops moving forward. I mean, can they survive with these kind of added or this change of roles or the added, kind of complexity to the repair?
I think the tough time for an independent is going to be the next 5 years. The industry has to change. The industry had to change 10 years ago. It didn't. It had to change 5 years ago. It didn't. The industry will have to change, but surviving that change is going to be a real challenge. Probably, it's going to be really hard to be. It's going to be really hard to be your local shop that fixes everything that comes in the door. You have to have the equipment, you have to be doing the work right, but it's just going to be too difficult to keep track of Asian cars, European cars, North American cars, Korean cars, which are also Asian. But so you're going to have to narrow down, likely you're going to have to narrow down the range of brands you do. And now if you're living in a community of 30,000 people, 200 miles from the city, that gets pretty tough. What do you do? There is not enough of one brand to keep you going, and the people with other ones are going to want to fix too. So it's going to be a challenging time for them. It's going to be a challenging time for an independent shop.
Yeah.
Unfortunately.
Okay. Well, thank you, Peter. Let's bring back Jeff and Ryan here and do and conclude a little bit on this webinar. We're almost at the hour here. So first of all, thank you, gentlemen. I really appreciate, working with you. You guys are professionals. This is fantastic, organizing these with you. So thanks. So probably some. I'm looking at the Q&A here quickly, and I don't see any comments. I think we asked a few questions. There was questions about the recording. I mean, this is recorded, so it's going to be available after on the CCIF website. But what? Any words of wisdom here to conclude, Jeff? Anything you would like to add here in conclusion of this?
Well, I would agree with Peter. Hardly, you're going to have to, shops, independent or otherwise, you're going to have to really focus on, a few specific brands, or narrow it down. I mean, we can't, we know ourselves. I think, for us, we're at our limit what we can process in terms of a certification. The cost of the certification, the tooling, every manufacturer has something different in terms of what they require from training and tooling, and it just doesn't make sense to be. It can't be, everything to everybody, right? So, being very specific on the certifications or alliances you have with manufacturers is probably a way forward. Absolutely.
Yeah, Ryan.
Yeah, thanks, Peter, for your comments. I do agree that taking the time to research a lot of this procedures for repairing cars, it's definitely time consuming. And I don't discount the fact that a full-time job could be created in some ways because of the amount of time that's spent doing it. And I also agree. I think that the industry is going to change. It's the introduction of the electric vehicle is one of those things where, again, there's a this push to keep things to not change, as with everything. Everyone just wants to be comfortable and keep doing the same thing they've always done. And the electric vehicle is going to change how the insurance companies deal with collision repair. It's going to change the way the shops deal with collision repair. Because it's an entirely different platform. It's an entirely different vehicle itself, and how you go about fixing those cars as time goes on and more electric vehicles flood the market. It's going to have a great impact on collision centers, and to Peter's point, the independents in the next 5 years, I think, are going to have a hard time dealing with it. So it's going to be a challenge for sure.
Okay, Peter, any final words?
My final words have to do with, I had no idea before we started, Patrice, what Ryan and Jeff were going to be talking about, and that was intentional on my part because I did not want to be doing a comparison. I just wanted to present my position. But as I was listening to them and knowing where I was going to be, what I was going to be talking about, I would like to think that they would agree with me here that if you took everything that Jeff and Ryan said and everything that I said, that you could merge all of that without a whole lot of disagreement at all. There would be a smoothing. There would be. Anyways, I think that the three of us were saying the same thing from a different perspective, but there was no disagreement in how complex the situation is and how to deal with it.
Yeah, no, I think so too. I think me too. As I was listening, I said, well, I mean, we do the research first. I mean, this in both cases, the importance is that do the research first, do your homework first, and then start fixing the car when you know what you have to do and you know how to do it. So that I think that's important. That's very important. So, hey guys, we're right there at the hour here, just a couple minutes past. So I want to say a big thank you for your participation here. Peter, thank you for your time. Jeff and Ryan, thank you so much for those videos. I mean, this is I mean, there's a lot of investment that's been put in this. People investment money to create those videos. They're fantastic. So thank you. Thanks for sharing this. Actually, thank you for sharing this information with the industry. It's very much appreciated. I really do. So I found them very, very interesting. There's a few more that we didn't get to watch. There was a few more clips on the electric vehicles that are just fantastic. I mean, I didn't know that you cannot wear anything that is conductive. I mean, hearing devices, things of that nature, anything that is metal, you cannot wear this when you fix an electric car. I did not know that. I watched that, I said, oh my God, I had no idea. So anything that can make you a conductor, I mean, you need to take that out. So, wow, we're talking about big voltage here. So it's, so yeah, that was good stuff. So hey, thank you very much. I want to say thank you. So right now at this point, I would like to thank the audience as well. So thank you for attending, and we will be doing this again in November. We will do another session in November. And again, if you're interested in submitting a topic and you would like to participate to be a presenter, you're more than welcome to do so. Just go to the CCIF website, find where the application form is under the speakers tab or something like that, I believe. But hey, thank you very much. And also, I'll just go through these as we close here, just to say thank you to our the CCIF supporters again, and we'll just get this the supporter slide going. So, thank you very much. Thank you for attending. The recording will be available on the CCIF.ca in just a few days after some minor editing. But thank you, and I'll see you tomorrow. We have another one tomorrow at 11. So thank you, everyone. Thank you. Thanks a lot.
Thank you.